since we were talking about that, and I know you've done Venn diagrams before, we use Venn diagrams to show relationships in sets. For example, if I was showing the relationship of circles and squares, this is what it looks like. Venn diagrams are nothing more than you put a circle that stands for all the subset or all the set of that thing. Circles would go here, and squares would go here, because there's no way that those two are even close, remotely close, or could be called each other. They don't intersect, they don't touch. No circles are squares. Okay? Don't worry, Mitch, because I'll get to the point here. You can say, well, why do I do that? I'm just to show you this. Because if we were talking about squares and rectangles, okay, if I have my circle that shows my square, and I wanted to show that with the relationship to rectangles, every square is a rectangle, correct? So that would mean when I did my rectangles, I would have to encompass the whole thing of squares. This is labeled rectangles, because every square has to be a part of the rectangles. Notice there's some parts of the rectangles that are not squares, because you can draw rectangles that aren't squares. But you cannot draw a square that is not a rectangle. So squares have to be completely stuck inside of the rectangles there. Now, what about rectangles compared to rhombuses? Think about this. First of all, what is a rectangle? Rectangle, what's the definition of a rectangle? Just has to have 4 right angles, right? What's the definition of a rhombus? Somebody? Exact definition of a rhombus, Isabel?
4 equal sides.
4 equal sides. Usually we look like this. If I was using a Venn diagram to show the relationship, here's the question. Could a rhombus be a rectangle? Can you have a 4 equal side thing? It's called a what? Huh? A square. Can you have a rectangle that is also a rhombus? Yes. Are all rectangles rhombuses? Are all rhombuses rectangles? So when you draw your circle, let's say this one stands for rectangles, and this one stands for rhombuses, what has to happen? Because there are some rhombuses that are rectangles, but not all of them. Those two circles do have to cross, but they're not fully contained in each other. You've got rectangles here, you've got rhombuses here, and then the place where they cross are squares. Because squares fit in both categories. A square is both 4 right angles, and it is both, and it has 4 equal sides. So when you do, Venn diagrams, you got to look at the intersection. And then, oh boy, we got some. I suppose they put that in. Go back to your sets, because I have to give you a couple more things here. Under sets, what a great day for this. We've got 2 other symbols. One looks like this, and it's called a union. And this one is called an intersection. Intersection. And the difference betwixt the two is, union is putting both together. And intersection is what they have in common. And again, you won't understand until we do an example. Ready? Let's say you've got set A set A equals these numbers. Set A is 1, 2, 3, and 4. That's just my set of numbers. Set B is 2, 4, 6, and 8. 2, 4, 6, and 8. If I asked you for the union of sets A and B, that means you put both of those sets together and every element of the set is an element of the new set. So you would have what? 1, 2, 3, 4, 6, and 8. You put them all together. You don't list them twice. But you don't put 2 1s or 2 2s or 2 3s. But you put them together. 1, 2, 3, 4, 6, 8. Union means you put them all together. If it's this upside down U, which is the intersection, it's what elements do they share? What do they both have? Well, if you look at both sets there, what do they both have? 2 and a 4, correct? So that would just be a 2 and a 4. Do you see the difference between unions and intersections? Unions, put it all together. Intersection, what they share or are in common. If you were going back to the whole Venn diagram thing of this, and you were doing a Venn diagram of set A and set B, how would that look? Well, do they have some elements in common? Yes, they do, right? So your circles would have to intersect. Here's A, here's B. Okay, the elements that only A have would go outside of the intersection, which would be what, 1 and 3. You'd have to put 1 and 3 out here. The elements that B have that A does not have, which would be 6 and 8, they would go here outside of the intersection part. And the ones that they have in common, which are 2 and 4, would go where the overlap is because they both have it. That's that whole Venn diagram, gizmo, gadget, whatever thing. Notice, that's the reason intersection. Union is all of it. Are you about done listening? Because I'm about done talking. No, you're not, because I got some other things. More, just write these down because these are helpful little things here. Under sets, for integers, natural numbers, integers, rationals, and reals. You have a chart on that, don't you? Natural, integers, rational, and a real. You'll like this because these are the mathematical symbols that sometimes you'll see that stand for those. If you see the letter N like this in a book, where this thing is double, somebody at the door or somebody knocking on my table. If you see this N that looks like this, that just stands for the set of natural numbers. Integers, guess what letter they use for integers? I know it's going to be hard. Anybody? Nope, a Z, and I don't know why. But I just thought I could get you to say I. If you see this fancy Z that looks like that, that stands for integers. Rational numbers, everybody taking a stab? Wow, good job. Q, whoever was looking at your book. And then real numbers actually does make sense because they do use the letter R. But notice they're fancy little R's. You got all these double lines going around. They kind of do whatever. I think they might even do this today. That's what it looks like in the book. I can't even see it. It's so small. Just because I know you don't want to work, bear with me. Look at page 603. Let's see if we can make any heads or tails of this whole. Actually, look at page 602. Look at letter A. It says, well, directions to indicate that if the number is an element of the set of integers. So for letter A, is -1 an element of the set of integers? How would you write that? -1 is an element of the set of what? Integers. So you have to put that letter Z there and do this. That is what you would write down. 1 is an element of the set of integers because we have that one little letter there. What about letter B? Is 2? 2 is also an element of the set of integers. How about -3? No. Oh wait, what? Square root of 3? Sorry. Is square root of 3 an element of the set of integers? So what do? Put a little slash mark. It's not an element of that. How about letter D? Use the subset symbol to show the relationship between A and B. If A is all triangles and B is all polygons, the question you ask, would all triangles be a subset of polygons, or are all polygons a subset of triangles? Which one is a subset of which one? Here's your choice, children. Is A subset of B, or is B a subset of A? A is the triangles, B is all polygons. Which one is a subset of which one? God bless you. Are all polygons, which are all shapes, hexagons, octagons, dodecahedrons, oh, that's a polygon. Which one is it? Is it all triangles are a subset of polygons, or all polygons are triangles? Why?
All triangles.
Yes. A would be a subset of B, because all triangles are a subset of the polygons. Is there more? How much more can we note this for? Oh, let's do this. Do letter G for me. Just sketch it on your notes there somewhere. I don't need it on these papers. Use a Venn diagram to show A and B, the relationship of set A to set B. Show me what would you have for the relationship of A and B on a Venn diagram? I don't know who Mr. Venn is or why he made a diagram, but apparently he's smart.